Hi everyone, welcome back to my channel Simony. It's me Vysakh. Today we are going to discuss motion in one dimension. So I want to do it as a two-part actually because it's a long topic. So in part one, we can discuss distance, displacement, speed, velocity, acceleration, and more on it. Good. So let's begin. So if a motion can be represented by a single coordinate, the motion is said to be one-dimensional motion. Good. All straight line motions are one dimension. For example, if I walk in a straight 100-meter race, or let me run in 100-meter race, that's a straight line motion, and it is one-dimensional motion. Good. Or else a car is moving in a straight racetrack, maybe a drag race, okay, is a one-dimensional motion. Good. Apart from that, pendulum motion is also one dimension, and train in a single track is also one dimensional. Now you may think, why is that? In the case of pendulum, it's going like this, right, back and forth. Now why I'm saying it is one dimensional, because any position of this pendulum or the bob, end part is called the bob, right? That bob position you can represent by a single quantity called the angle subtended with respect to the vertical. So at any time its position is unique, right? This theta is unique. Good. Now for a train, even though the rail track is in two-dimensional, you can describe the position of the train by counting the parallel wood, right? So that's why it is one dimension. Now let's focus on what is the difference between distance and displacement. Let's say I'm in a hiking and I want to start my journey from A to B to, so from this region to this region. Of course, I'm not going in a straight line. So imagine that I'm going in a curved path like this. So the total length of the path covered is the distance. Good. Now, what is the displacement? The displacement is the shortest path from the initial point to the final point. Of course, I cannot walk or run like that, right? Maybe a drone can go in a straight line. So that will be corresponding to displacement. Now, moreover that, the main difference between distance and displacement is that displacement is a vector, distance is a scalar. That means distance doesn't have any direction, displacement has direction. Okay. In general, we can say displacement is the shortest distance from the initial point to the final point, or in another word, it is a vector directed from the initial point to the final point. Good. Now distance is usually represented by delta x, where delta corresponds to change. Something is changing there, right? Our position is changing. Now displacement is represented by delta x over right arrow. Right? Good, because it is a vector, right? As an example, a person walks 200 meters eastward and then 400 meters southward. The question is, find the total distance covered, and second question is, find the total displacement. For that, let's draw a small diagram. First, the person walks 200 meter forward. First, a person walk 200 meter eastward. So let's denote that 200 meter eastward. After that, the person goes southward. Now, of course, the distance covered will be 200 plus 400. So for finding the distance, we don't have to consider the direction at all, right? So distance directly you can write distance equal to 200 plus 400, because it is the length of the total path covered. Now, what about the displacement? Displacement is a vector from the initial point I to the final point F. So we can draw a direct vector from point I to point F, initial point to final point. So length of this vector give you the displacement. Now how to find that? Displacement vector, I can write it as delta x vector. Now delta x vector I can write like 200 I cap minus 400 j cap. This is equivalent to writing 200 eastward and plus 400 southward. I'm considering northward as positive. That's why this that's why I'm writing 200 I cap minus 400 j cap. Okay, because j cap, positive y direction, usually it is upward, right? Good. Therefore, the magnitude you can write modulus delta x equal to square root of 200 square plus 400 square, which is square root of, 100 square you can take outside into 2 square plus 4 square, right? Therefore, you can take the 100 outside. So 100 into square root of 4 plus 16. So 100 square root 20 meter will be the displacement. Good. So that's it. Very simple, right? Now let's focus on speed and velocity. Speed is the change in distance divided by the change in time. Change in distance divided by the change in time, or distance covered per second. Okay, so we can write v equal to delta x divided by delta t. I will explain in detail. Please wait. So velocity v vector is the change in displacement divided by the change in time. So v vector is equals to delta x vector divided by delta t. Remember, this is distance and delta x vector is displacement. Good. Right. Now here is an example. A car, this red car is going 30-meter eastward and 40-meter northward. That means 30-meter I cap and 40-meter j cap. Good. Now how to find the speed? For that you need time duration, right? For covering 30-meter, the car is taking 10 seconds. Now for covering the next 40-meter, it is taking 20 seconds. Therefore, the speed v equal to 30 plus 40 divided by 10 plus 20. Total distance is 30 plus 40 divided by 10 plus 20, which will be 70 divided by 30, 7 by 3, which is 2.33 meter. Good. Now velocity, for for finding velocity, you had to find the displacement. Displacement is 30 I cap plus 40 j cap, and you divide that with the total time duration, which is 10 plus 20. So 30 I cap plus 40 j cap divided by 30, which will be I cap plus 4 by 3 j cap. Good. So that's the velocity vector. Now if you want the magnitude information, you can do square root of x component square plus y component square, right? So it will be square root of 1 square plus 4 by 3 square. So it will be square root of 1 plus 16 divided by 9, which is of course square root of 25 divided by 9. And finally you will get 4 by 3 meter per second. Good. So look at the magnitude. Speed is 2.33 and velocity magnitude is 5 by 3. Entirely different, right? So I'll give you a funny example. You walk 10 meter forward in 10 seconds and you return back the same distance in another 10 seconds. Now pause the video and think, what is the speed and what is the velocity? The answer is, I travel 10 meter forward, 10 meter backward. So total distance covered will be 20, right? So 20 divided by total time duration, 10 plus 10, it will be 20 divided by 20, which will be 1 meter per second. That will be speed. Now, however, for the velocity, look at the displacement. You move 10 meter forward and you come back the same distance, right? So 10 I cap plus minus 10 I cap. So the displacement will be 0, right? It is the distance between initial point and final point. In this case, initial point and final point are same, right? So displacement is 0. So even though I move forward and come back, my displacement is 0, and of course the velocity will be 0. Good. Right. Now direction of this velocity, if you want to find, you can just find theta equal to tan inverse 4 by 3 divided by 1, the y component divided by x component, right? So the answer will be 53.1 degree. That means this angle will be 53.1 degree. Got it? Right. Now let's focus on speed and velocity from x versus time table, okay, xt table. So imagine you are dropping a ball from 100-meter building. In the first second, it is at a distance 95.1 from the ground, okay, and in the next second, that means in the 2 seconds, the position is 80.4 from the ground. Now, of course, the next distance will be larger. In the third second, the distance is 50.9 from the ground. Now, in the fourth second, the distance is 21.6. So, of course, you may experience it when you release an object. Initially, the distance covered will be less, but gradually it will increase. Correct? So, that's what summarized in the table. At the zeroth position, that means initially the ball is at 100 meter. First second 95.1 and so on, and it reaches a position 21.6 from the ground at second 4. Now for these all time intervals, you can find individual speed or corresponding speed. So speed for this 0 to 1 time duration is speed v1 equal to 95.1 minus 100 divided by 1 minus 0, distance covered divided by time duration. So we are getting negative 4.9 meter per second. Why negative? It's going downward, correct? All right. So it'll be useful when you use the velocity, right? Now, second case, V2 is equals to 80.4 minus 95.1 divided by 2 minus 1, which is negative 14.7, and V3 similarly negative 24.5, and finally you will get V4 negative 38.3 meter per second. Now look at the trend here. The velocity is gradually increasing. Now let's explore the new term average speed. What is average speed? We can calculate average speed by finding the total distance divided by total time. So the total distance in this table is 100 minus 21.6, correct? So 21.6 minus 100 divided by 4 minus 0, which will be 19.6 meter per second. Good. Right. Now there is another term, instantaneous speed. V inst is given by change in position divided by extremely small time duration. Oh, what is that? See, if you compare the average speed with this speed, you can see the values doesn't match. This time duration you just reduce, maybe like 0.01, and find the corresponding change in position. Then if you divide it, you will get the instantaneous speed. Good. For example, in a bike, you travel 100 meter and divide that with time. You will get the average speed. But if you look at the speedometer, you can see the speedometer, the needle is varying. That needle will vary from 0 to maybe 50 kilometer per hour, right? So at a certain position, it is in somewhere in between 0 and 50, right? So that particular speed at a particular time is known as instantaneous speed. Got it? So the speedometer will always give you instantaneous speed, not the average speed. For finding average speed, you have to measure the total distance traveled and divide with the time duration. Got it? Great. So please note that to find the instantaneous speed, we should use either graphical method or equations of motion. This is going to be covered in the part 2 of the video. Good? Right. Now let's concentrate on acceleration. Acceleration is denoted by small letter a with overright arrow. It is defined as the rate of change of velocity. Good. Now, similar to the speed or velocity, there are two different approach. Average acceleration is change in velocity divided by time duration. That means delta v divided by delta t. Now, instantaneous acceleration is A instantaneous equal to value of delta v by delta t for extremely small value of delta t. So, as an example, here is a question. A car accelerates from 10 meter per second to 30 meter per second in 6 seconds. Find the average acceleration. It's very simple. A is equals to 30 I cap minus 10 I cap divided by 6. Now, why there is I cap? Because the velocity, we are assuming that it is towards right. Okay, good. So it will be equal to 20 divided by 6 I cap, which is 3.33 meter per second square. Now let's focus on example number 2. A biker is moving with the speed 40 meter per second, finds a dog suddenly crossing the road and stops the bike with a deceleration 10 meter per second square. Find the time by which the biker can stop the bike. Now how to do it? See here, A is equals to delta V divided by delta T. That means average acceleration is delta V divided by delta T, which implies delta T equal to delta V divided by acceleration, right? We are just rearranging this equation. So delta T will be 0 minus 40 divided by negative 10. Why 0? Because final velocity is 0. Of course, the biker has to stop the bike finally, right? That's why it is 0. And the answer will be negative 40 divided by negative 10. It will be 4 seconds. Why we choose negative 10? Because this is a deceleration. Acceleration is in the negative direction. Good. So the answer is 4 seconds. So folks, that's good for today, and we'll be discussing more about the motion in one dimension in the second part, in which we'll be covering about kinematic graphs and equations of motion. Good. So stay tuned. See you soon. Have a great day. Bye bye.